Good morning. Today we are going to see GE6757 Total Quality Management, Unit 4. The topic is Taguchi Quality Loss Function. Quality loss concept. By seeing the graph, seeing the drawing slide. According to Taguchi, what he is saying is, I want zero defect. My component should be exactly on the center. Anything going away from the target is a loss for me. So, deviation from the target is a loss. Lower than the target or greater than the target, both are loss. Even though the components are within the specified limit, upper limit or lower limit, the component is okay, but the component is away from the center. It is in this graph, it is yellow. So in this yellow line is going out to say both are loss. So this is the main concept of the quality loss. Quality loss means zero defect, away from center. Definition for the Taguchi quality loss function is defined by the Taguchi is the loss imparted to the society by the product from the time the product is designed to the time it is shipped to the customer. The loss may be due to failure, due to repair, due to variation in the performance, pollution, noise, etc. Once it is leave from the design department, it started adding quality loss to the customer. Taguchi என்ன சொல்றாருன்னா, ஒன்ஸ் அந்த ப்ராடக்ட் வெளியே வந்த உடனேயே கஸ்டமர் ரீச் பண்றதுக்கு முன்னாடியே சொசைட்டிக்கு வந்து இட் இஸ் ஸ்டார்டிங் லாஸ் டு சொசைட்டி. என்ன லாஸ்? மேபி கெட் ஃபெயிலியர் ஆகலாம், get repaired, variation in the performance, pollution, noise, etc. Taguchi loss function introduction. Taguchi has defined quality as the loss imparted to the society from the time of the product is shipped. Second point is social loss. What is social loss? Failure to meet customer requirements. Failure to meet ideal performance, exact ideal performance. And harmful side effects. Harmful side effects, if we take a cell phone, but it is useful, but radiation is the sideful harm. If we take micro oven, it is useful, but radiation is the micro oven. If we take nuclear power plant, it is good, but side effect is the harmful side effect is the nuclear waste. It cannot be properly disposed. So by assuming the target is correct, the loss of concern are those caused by the product critical performance characteristics deviating from the target. Whichever the quality character which is going away from the target is there is no use for the customer. This makes dissatisfaction to the customer. At the fourth point, the loss met by the customer when the purchased product not fulfills the required performance, even though it is accepted for technical specification by quality control department. Component found to be okay, but it does not deliver the exact performance required 100%. If it is less than 100%, it is loss for the society, loss for the customer. So it is very difficult. We take a pen, it's supposed to write 100% fully. In between, it is gets stuck. It's a problem. So even though it is very good pen, but it is not fulfilling the required performance, it is lost to the, as we say, our customer. So it leads to the dissatisfaction of the customer. According to customer perception, the product that barely meets specification is as good as product that is barely out of specification. அதாவது ஜஸ்ட் ப்ராடக்ட் ஸ்பெசிஃபிகேஷன் மீட் பண்றது வந்து அது வந்து ஈக்குவல் டு தி ரிஜெக்ஷன் காம்பனன்ட் தான் சமானம். ஈவன் தோ barely meets specification, but it seems to be almost equal to the out of specification only. So this loss function is called Taguchi quality loss function. என்ன சொல்ல வர்றாருன்னாக்கா, ஜீரோ டிஃபெக்ட், I want exactly zero. Say for example, for the ladies are going to take this blouse matching. The blouse matches is exactly the same color of this, almost same. If it is contrast, it will be different for them. So there is a problem for this. This is a simple example. You can find out the quality, Taguchi quality loss function. So what is the difference between Taguchi approach and the traditional approach? So if you consider the two products, one is within the specified limit, other one is outside the specified limit. In traditional approach, say for example, the diameter is equal to 30 plus or minus 2 mm. So if it is 32 and 28, the component between the 32 and 28, it is going to be a good one. It is going to be a good one. Traditional approach, the product which is limit considered as a good product, which is while outside one is a considered. So if you take example of the example, if you take example, the components lie between 28 and 32 are okay. They go a little less than 28 and above 32 is going to be rejection in the target traditional approach. But Taguchi, what he is saying is, whenever the product moves away from the target value, that move causes no loss, no matter if the move falls inside or outside the specified limit. Whatever may be, either it is inside or outside, once it is away from the center, there is no use for being run. That is the main thing. Uploads 100% perfect. That is here towards a zero only. Traditional approach, if you see the drawing in this one, lower specified limit, upper specified limit, in between this, all the components are found to be good. Other than that, the products are going to be unacceptable. All products within the specification equally good. All products outside the specification is equally bad. This is called a traditional approach. Normal approach la pathina, எல்லா componentum whichever fall between the upper specified limit and lower specified limit is found to be accepted, good. Out of வேலை போச்சுனாக்கா, that is called rejection. The drawing pathina, you can able to see the drawing variation. That is interpretation of the loss. Upper specified limit, lower specified limit, upper target, the value characteristics, the shaded area is called the loss. So the variation away from the specification is the loss to the society. The example, the lower limit is 10 and the upper limit is 20, the measurement is 19.9. The customer satisfaction measurement of 20.1 leads to the customer dissatisfaction. So 20 plus or minus 0.1. So the problem of 20.1 is going to be a rejection. Next, if you are seeing the same thing, if you are going to consider as a loss in the Taguchi, what he is saying is the graph. Previous graph, if you see the upper specified limit and lower specified, only they have shaded value, it is called the loss. In Taguchi, from the center line, this area also is going to be a rejection. Even though the components are between LSL and the VSL, these are also acceptable in the traditional approach, but Taguchi is not acceptable. So it is very, very difficult to acceptable. So say for example, the measurement is 19.9, customer dissatisfied more than measurement 19.8. The measurement is 20.1, customer is slightly more dissatisfied than 19.9, almost same. So we need exact specification, center only. You see the graph, you see the drawing, you are having orange. So LSL, LOSL, day 1, day 2, day 3, day 5, day 7. Exactly, if you take day 1, it is only a shore. But day 3, somewhat it is good, but it is not up to the satisfied limit. And between middle one, day 5, it is going to be a very good, useful. So day 7, it is good, but day 8, it is rejected. So even though the day 3 and day 7 components are, remnant proofs are found to be okay, but the difference of the taste is going to be changed. By seeing this figure, you can able to easily understand the Taguchi loss function. Very simple example for Taguchi loss function. Seeing the graph, over it is a loss, upper specified limit, lower specified limit, target, poor, fair, good, best, good, fair, poor. But it is okay. But I need this one only. So whichever the target component or the quality characteristic going away from the target is lost to the quality. That is called quality loss function of the Taguchi. Example, if you take a example 30 plus or minus 3. Say for example, if the component is measures below 27 and more than 33 is rejected, traditional approach. So 27 to 33 is no quality loss cost. But Taguchi, what he is saying is, even though the part does not reach the exact 30 mm, the variation of the target 29 or 31, the product produces a quality loss to me. It's a main thing. Say for example, the small example is a zero defect. Where it's come into play is, suppose you are going for the hospital for life-saving medicine. The number of components which is going to be getting rejected is 100%. I want 100% exact medicine I want. We say the combination changes, even though it's good, but your side effect will come to them. So it never lasts to the society, customer only, society only. So if you say example, if you take a polythene bag, you take example of polythene bag. Instead of 30 mm, you can take polythene bag for the preserving fertilizer bag. So 30 mm is the thickness required. Plus or minus 3 mm is specified. Even though the component for the manufacturer side, 27 mm is the manufacturing cost. So it is a saving of 3 mm as a benefit only. This is benefit to the manufacturer. This is going to be the benefit for the customer. So such a 27 mm thickness. So basic benefit for the manufacturer. If it is 33 mm thickness, the component polythene bag is good. But what we required is 30 mm thickness only exactly. So whichever the target, traditional, these are the losses, but Taguchi full curve is lost exactly. I need a 0. So for example, this is a drawing. It's a drawing given for the TV manufacturers color distribution. So first factory A, it is going to be this one. Second factory is B, but the people select only A factory because the frequency is modulated towards the center line. So the clarity should be very good. So the B is going to be get rejected. Television set, same company, different countries, but they manufacture only particular product only. So it is Japan manufacturing, USA manufacturing. The people prefer only Japan manufacturing because the concentration is going to be exactly center. So for example, this is a graph. It is a quadratic quality loss function. This is lower specified limit, upper specified limit, scrap or river. This is loss. This is x1, x2. So Taguchi quadratic loss function, as discussed, quality loss occurred in the product's specification deviates from the target or normal value. No matter how small the deviation, there is some loss of quality. The deviation increases, the value increases, loss increases. The Taguchi shaped the loss function. L of x is equal to k into x minus n the whole square, equation 1. L of x is equal to loss function. K is the constant of proportionality. X is the quality characteristic of the selected product. N is the nominal value of the chosen product. X minus n is the tolerance. Quality equation 1. By considering K in equation 1, K is equal to C by D. C is equal to loss associated with the specification limit. D is equal to deviation of the specification from the target value. The value of the K determines the slope of quality function. Example, on the derivation, you can see that only that equation writing is sufficient for the value of L of y is equal to K into y minus m square. The Taguchi loss function is given. Then the types of quality loss function. What are the types available? Normal, the best. Center is the radius required is going away from center line, this line. In this approach, the closer to the target value, the better. It does not matter whether the deviation is above or below target value. Under this approach, the deviation is quadratic. The following exhibit portrays the normal is the best approach. So normal curve. Whenever the normal bell curve comes, which is minimum lowest is the target value. So this is called normal the best. So towards center line is the normal the best. So one quality loss function. Another one, smaller is the better. So quality, when it comes very less, quality loss is least. So it becomes a quality characteristic, quality loss. Whenever the quality characteristic increases, the loss will be more. So the smaller the better approach is the company, they say smaller the value. Say for example, background density of the text image, radiation leakage in the nuclear power plant, corrosion of metal should be very less. Signal to noise ratio, defects like pinholes, particulates in the deposits of the person, unwanted byproduct or statement. Smaller the better. Suppose if you take a calculator, if you say the multiplication, 3 into 6 is equal to how much? It will take 2 to 6 minutes. What will happen? The problem for you. So the loss will be very, very micro level. So smaller is the better. First one is normal the better. Second loss is smaller the better. So third loss is larger the better. Larger the better means the loss will be larger. The quality loss will also increase the quality characteristics. So larger the better occurs when the company decides a higher value of the characteristics. Two examples given are employee participation and the customer acceptance rate. Under that, larger the characteristics, smaller the quality loss function. So if the portraits are larger, the best approach. Example is, if you are fixing the two components, the bond thickness increases, the pasting with the bond thickness increases of the two pastes, the quality, the holding capacity will be more. The welding tag, by putting a welding tag, more tag, the strength will be more. Then critical current value. So three types are there. So we have to see then last uses of the loss function. The last for 2 mark question. So the total loss due to deviation of product from the target value can be easily calculated. The two processes can be compared and the best can be selected. Reduces the cost of manufacturing. Setting up the specified limits. இதில் வந்து they last normally for 8 mark question. Discuss briefly about Taguchi loss function. நீங்க எழுத வேண்டியது first definition for loss function. Then you have to say the two drawings for traditional approach and the Taguchi approach. Then you have to derive derive the equation, quadratic equation. Then you have to write the types of the Taguchi loss function, then uses of the loss function. The question they'll ask a question for 4 mark question. Discuss the type of the quality loss function. You have to write 3 types of losses. So as an overall view, what is meant by Taguchi loss function is I need zero defect. That means your quality will be always stick on to the center line only. So we can continue in the next video.